Waves are interesting not just because of the fact that they can transfer energy without transferring matter, but also because of the fact that they can interact with each other. When we're talking about matter, we studied its interactions a lot first semester when we talk about things like momentum and energy transfers, and it's not surprising to us, but waves do the same thing, it just looks a little bit different. So there's 4 basic categories of wave interactions that we want to know about. We're going to talk more in detail about them when we study sound and light. But to start with, we just need to have a concept of what these 4 terms mean. So, first one, reflection, we'll talk about. Second one is refraction. Third one is diffraction. And finally, we'll talk about interference. So let's start with reflection and refraction. Reflection and refraction both happen when a wave meets a new medium. So we've talked about mediums, and we said that there's one kind of wave that needs to have a medium, and that is a mechanical wave. Electromagnetic waves, on the other hand, do not have to have a medium. They can travel without a medium, but they still can enter a new medium. So something like light that doesn't have to have something to travel through can indeed travel through something like air or water, as you've seen, windows, things like that. So whenever a wave hits a boundary, it's going to do some reflection and some refraction usually. Reflection is when it hits that boundary and it bounces off. It comes back into the original medium that it was in. Refraction is when it continues to travel and it goes into that new thing, but instead of continuing on in a straight path, it actually gets bent. So reflection and refraction. Let's go ahead and look at something that we often use to study wave interactions is these little wave pools, they're called. And what was just has, it's like kind of a tray that has some water in it. So this is a video of one of those. And we're going to be able to look at what happens to the waves as they're coming in. So let's look at this together. So this is just a wave pool. It's just being reflected onto a screen. And in the pool, originally, let me go back a second, see if I can do that. Let's go back to here. You can see here that we just have the waves being propagated from one side of the screen to the other. So there's just some sort of little paddle going back and forth, and we just have these up and down waves going across the screen, moving across the screen. What's going to happen now, and I'm going to slow it down just a little bit. What's going to happen now is they're going to place a barrier in there, and that barrier is going to be what causes us to see the waves get reflected. So there's the barrier. So now what's coming as the waves get reflected, the waves are coming in just like they were before. Let's see, I think I can write on here. So let me do that. They're coming in just like they did before, but now instead of those waves continuing on, the barrier gets in their way. So we had the waves coming in right here, and now, or maybe I can't write on this. That video might not, it looks like I can't, sorry. I just keep starting the video over and over again. So the waves go in this way. I can't write on the video itself. But then when we're back over here, when the barrier comes, now the waves are being deflected this way. And now a different barrier has been put in that's allowing the waves to be reflected the other way, and even a curved barrier can reflect the waves back. But you see the waves don't continue on, but instead they bounce back. That is reflection. Now we want to look at refraction. That's not the same thing. So it's not that they can't continue on. The waves in refraction are allowed to continue on, but they don't continue on in the same speed that they would have otherwise.
First encounters a piece of glass. One side is slowed down before the other, forcing the wave front to change direction.
So you can see that the waves move slower when it comes into the white section. It's moving faster in the green section. And that's causing that bending. So instead of it continuing on in a straight line over here, you see that bent.
Closer to the direction perpendicular to the interface whenever it enters a medium that slows it down.
So you see there's always a bending in of light.
This occurs no matter what the direction of incidence.
And that doesn't matter where it comes from. It always is going to bend closer in. Now, if it comes straight on, then it's going to go straight through. And we use that as about to show you how we can use that in optometry and things like that. So first two things were reflection and refraction. Now we're going to go into the other two, and that's interference and diffraction. Interference and diffraction are a little bit more different because they're not talking about hitting a new medium, but instead they're talking about the wave interacting with something else. In the case of interference, the wave is interacting with itself. So one wave meets another wave. If those waves meet crest to crest, those crests are going to be doubly as big. If those waves meet crest to trough, they're going to cancel each other out, and so on and so forth. Diffraction, on the other hand, is when waves get to a small opening, they actually are caused to spread or bend a little bit. And we'll look at both of those situations again in the wave pool. So let's start by looking at interference. In this situation, we have a wave pool with these two source points. These points are going to be what gives us the wave in the pool. So this is just a shallow tank of water, and then they're going to go up and down. As they go up and down, they're going to create waves coming out from the actual source point. And then since there's two of them, they will meet in this middle section. So let's go ahead and see what that looks like. I'm going to slow that down a little bit. So let's go ahead and watch that. So this is what you're looking at. This just kind of shows you this setup, that ripple tank or wave tank. And then there's a mirror down here that will reflect it so that we could see it on the pattern on the screen. They're both tapping the surface of the water, creating waves, and we're going to look at what happens between them when those waves interfere. They run into each other. So the lights are off so that we can now see that reflected on the screen. And you see this nice pattern here. This is called an interference pattern. You can see on the edges here, the waves just go out, but in the middle they kind of pile up, and we can see these like really dark spaces and these really light spaces representing the crests and troughs. Now it's going faster and faster. It's making a different interference pattern as it goes along, and you can see those patterns as it continues. So that's interference. We'll talk more about that when we talk about light. And then the last one is diffraction, and this diffraction is going to show what happens when there's this small opening. Again, on the back side of this in the ripple tank, we have some sort of source of the wave, and then the wave, when it hits this barrier, it's going to reflect inside here, but there's this gap in the barrier that's going to allow it to go out. And notice that it doesn't just come straight out in a flat line, but there's actually a curved pattern to where that comes out. So let's watch that again. See the curved pattern that comes as it goes through those small places? That's diffraction. So that is wave interactions, the 4 of them that you need to know. At this point, what I mainly want you to know is just basically what scenario would happen to cause each interaction and what each interaction is. You can start thinking a little bit about what are some experiences that you might have had that show some of those interactions, and we'll talk more about them next week when we talk about sound and the following week when we talk about light. Have a great day.